Hi everyone, welcome to the December online chapter meeting of the Building Designers Association of Australia, our last one for 2020. For those of you who don't know me, I'm Jennifer Binns. I'm a building designer based in Tasmania and host for the online chapter meetings. And I'm joined by Sarah Jane, managing technology in the background. Post a message in the chat box and let us know where you're logging in from. It's great to have you all with us, and a special welcome to those joining us for the first time. We didn't have a November chapter meeting due to the National Virtual Design Conference, which was a very successful event. Hopefully many of you were able to participate in the sessions and got a lot out of it. It was a different way to experience the conference, so I know I really enjoyed it. For those of you who chose the All Access Pass, the conference content is now available online for you to revisit any sessions that you missed or want to watch again. We have two guest speakers today, Larissa McCollin, who's a glazing professional, and Graham Hunt from Dalal Hunt Wood. Before we get started, I'll just do a quick run through of the Zoom tools, although I'm sure you're all very familiar with them by now. We welcome you to ask questions throughout the meeting. There's a Q&A box for questions, and our presenters will answer the questions either throughout the presentations or at the end. If you'd like to ask a question via audio, there's a raise your hand tool, and we just ask that you check there's no background noise that will interfere with the audio when we unmute you to ask your question. The chat box is also there as a continuous message thread, and SJ will also post links in the chat box if we need them. So today our first presenter is Larissa McCollin. Larissa spoke at the National Virtual Design Conference and is a glazing professional with over 25 years of experience in design, promotion and training in the use of glazing products. Larissa has worked on many major commercial high-rise projects globally, as well as residential and restoration projects on a more personal scale. Today, Larissa is going to be giving us an introduction to the concepts behind acoustic glazing design and is joined by Greg Milne, who is the General Manager of Viridian Glass in Queensland. Welcome, Larissa and Greg. Have we got you both online ready to go?
Yes, I'm here.
Hi, Larissa. I'm going to hand over to you.
Thank you.
Thank you.
Hi, everybody. My screen should be coming up momentarily and I'll be able to share some information with you. Yes, thank you, Jennifer and the BDAA for welcoming me to do a presentation for you today. A little about myself. I am a design draftee with many years of experience, and I've spent the last couple of years really doing a lot more in specification, consulting and training with building designers and architects. So it's great to be able to sort of chat to you today a little bit about knowledge that I've actually gained over my career. And so today, my basic background is in aluminium, but I will touch a little bit on timber and UPVC windows as time goes on. The other thing I'd like to mention, it's actually, or UNESCO has declared it the International Year of Sound in 2020. Now, due to the pandemic, that's actually going to be extended into 2021. So if you actually have any personal interest in acoustics, it's a great time to find out information because there's plenty of it around. So the aim of today is to gain a basic understanding of acoustics and to provide you with awareness of regulations surrounding it. And so hopefully you'll be able to provide an improved service offering to your clients. So let's start by considering what noise is. There we go. Is there a difference between sound and noise? Well, which is preferable? A waterfall tinkling in the background or a tap relentlessly dripping? So your definition of noise is probably going to be a little bit different to another person's. So it's up to personal interpretation. But generally, we all know what is considered unpleasant. With urbanization, we have more traffic, crowds, increased industry, we have changes in development. All of these contribute to a system that's, or to a situation that is not necessarily conducive to living harmoniously. What I'd encourage you to do is to start considering what bothers your clients in the acoustics of realm, whether it's dogs barking, car alarms at night, your neighbour's proud Harley owner on shift work. Take the opportunity to learn more about your client and make them feel that they've been provided with a more focused service for their specific needs. So sound. Sound is actually energy, and it's transmitted by pressure in airwaves. So basically, as you speak and sound leaves your mouth, the airwaves bump into other airwaves, creating a domino effect. And then they bounce around the atmosphere around us and off surfaces around us until that energy actually dissipates. The concept of acoustic attenuation is to stop or absorb those energy waves. So sound is actually measured in decibels. It's not a linear measurement. The actual sound level doubles with every 10 decibels you go up in height. So when you actually have a look at these factors here, and we've got a pin falling at 15 decibels right at the very bottom, and then it goes up, and then conversation is at 65 decibels. Traffic is a good one to know, and that's at 78 decibels. But a lawnmower is twice as loud than a vacuum cleaner. A jet taking off is 140 decibels, and the one at the very top there is 160 decibels, and that's a 12-gauge shotgun going off. So the weighted sound reduction index, or RW, is how we rate products in relation to sound. So basically, the higher the RW rating, the more acoustic protection it gives. Oh, jumping ahead there. RW ratings appear with tested products, and so you can see them in this table. And different products will have a different RW rating depending on the testing the results of testing. The RW information is the same across the board. So whether it's an aluminium window, a timber window, or a UPVC glazing. You'll notice that the RW figure has a couple of other numbers behind it in brackets. That's referring to the frequency. So I'm going to do a little experiment with you now so you can understand exactly what frequency is. So what I need you to do, I'm hoping you're all sort of at home in a nice office tucked away and no one will be able to hear you or see you, so there's no embarrassment. But take a couple of fingers and place them against your throat and then make a high-pitched sound. Ah. I'm not going to make it too high, I don't want to deafen you. And then keeping your fingers in position, now make a really low-pitched sound. Ah. Between those two, you should be able to feel the difference in the vibration in your throat. And that actually gives you a bit of a concept of what a frequency is like. In a sound wave, the frequency can be distinctly different. And so if you have a look at this information here, you'll see that the frequency of sound changes over distance, as in a jet engine, and the proximity of where you are to it. Now, in a sound wave, sound is actually on the global agenda due to health and well-being health and well-being in general. Any long-term exposure over 85 decibels, and that's about halfway between a vacuum and a lawnmower, is actually hazardous for your ability to hear. So that's over long term. And I think that we've all visited like minimalistic, sterile restaurants and cafes where, you know, you've got nothing on the walls, you've got chairs that scrape, cups that clink, coffee machines that whir. And between that and a few jovial customers, it's really hard to hold a conversation. So what I'm trying to do is bring awareness generally to everybody to make a difference when they're actually looking at design. Now, there are Australian standards that discuss nominal acoustic protection. And in New South Wales, it's suggested that the decibel rating for a bedroom is no greater than 35 decibels at night and 40 decibels for other areas of the house. This is just a guide though, but one we can all bear in mind with design. Now, that doesn't matter whether you're in a rural area or you're next to a railway track or a massive road. They don't differentiate very much at all. That's just a general guideline. However, if your project is in proximity of an airport, standards allow that decibel level to be raised to 50 decibels in the bedroom and 55 for habitable areas. Now, councils are the ones that will enforce this code if they deem it is required in their basin. Apart from that, commercial premises, actually there is a code that governs acoustics in commercial premises, but only in class 2, 3 and 9C buildings. And that's more for recreation, sleeping and work areas in those class buildings. So other than that, commercial premises must be individually assessed and is up to councils or clients' decisions. That will, so really what they're doing is you need to have a look at the environmental effects and of the surrounding development and the sources of noise, but also consider internal partitioning. So what acoustic measurements might be appropriate for reception areas, particular offices, say meeting rooms or restaurants where they divide things off. Local councils, however, are starting to enforce acoustic protection, and in particular in Brisbane, I'm aware of 5 precincts that actually have acoustic caveats on them, and council will be looking to make sure that those acoustic ratings are aligned. Now, the only way to know how much sound a place is exposed to is to measure it. And an acoustic engineer is the person to do this accurately. You can understand that if this house in the image here is near a sports stadium, the complexity of measuring it is difficult without an engineer's proper appraisal. And they'll look at all of those windows, no matter the height, the aspect, the elevation, the size, and they'll rate each of those individually with a rating, an RW rating that needs to be abided by. So that assessment might include noise from the stadium, increased traffic around the area, or revelers and things like that. I'm just going to keep going. I think there might be a few people asking questions, but I'm going to punch through this and we'll get to the questions right at the end, because there's a little bit of information. There's a bit of information here that I do want to go through, and maybe I'll answer that as I'm actually going. The only way to conform to acoustic requirements on a project is to use tested systems. Now, and that doesn't matter whether they're made out of aluminium, timber, or UPVC. And the way testing is done is by using a couple of soundproof chambers. One will have a sound maker, the other will have a sound monitor, and the glazing is fitted in a hole in between them, and then they measure that. So they measure the loudness and the frequency, and they're measured with devices such as shown in that image there. So that figure will reflect, okay, so you've got 2 figures then. You have the figure for the product itself, the glazing product, and you have the figure for the engineer is requiring, and that will actually reflect the RW and the CTR factors, and then you match the product up with the project that you're working on. There is a standard that governs the testing, and that's AS 5218. And it's the only standard that's currently affiliated with acoustic controlling and glazing, so it's one to be aware of. So in the initial stages of design, it is sensible to be aware of the appropriate frame types and potential glazing options. So think about a project you're currently working on. What do you think adds to the glazing acoustic ability or its weak points to stop air movement getting through gaps and weak areas of design? So if you think about the frame material and the type of frame, if you think about material wall thickness, the solidity of a frame as opposed to actually insulative chambers, both can be quite insulative. The seals that they use, whether it's gaskets or wool piles or wet seals, the installation of glazing and drainage design. Now, often there's little air gaps there that sound can get through. And the glass type. And Greg's going to talk about that in a little bit, but I'm just going to talk a little bit more about the frame options. So when it comes to glazing, a positive close is where one surface will close against another, a flat to flat. This allows for better sealing and air isolation. So if you think about sliding windows and doors or double hung windows, the sliding action doesn't allow them to close flat on flat. So unless they're specifically acoustically designed, that's going to be a problem area. Then you've got hinge doors, not pivot doors, but hinged or bifold doors. They will close against an area, but there's still room for sound to get through. Awning encasement are the strongest operable glazing options. And if you consider the size of them, that actually sort of gives you a bit of an indicator of why they are better at keeping sound out. And the best of all that you could choose are fixed glazing. Now, I've spoken to a UPVC designer that claims that UPVC products will provide the same acoustic control whether it's actually fixed or not, or operable. But they are relying on standards or tests that have been done in Europe. There aren't, to my knowledge, any UPVC testing that is done to acoustics at this stage. So unless it's done to Australian standards, it's not going to actually pass, especially if you have a stringent quality control on those. As soon as you're aware that you have an acoustic issue on a project, the best place to go is the AGWA website, the Australian Glazing and Windows Association. And they have a list of glazing system suppliers that have acoustic testing that they offer. So the other part of the glazing that actually affects this is the glass itself. So I'm going to hand over to Greg now, and he's going to go through some of that information with you. Greg, are you there? Okay, now I'm having trouble hearing Greg if he is there. So I'll just field this for now. He may have been held up somewhere or having trouble logging on. All right, so there's two basic principles. The thicker the glass, the more acoustic protection you get. The other one, oh. Greg, is that you? Okay, maybe he's not there. All right, so yes, and the second principle is different thickness of glass absorbs different frequencies. Now, this is where the frequency factor comes into it a little bit more importance. In the first, note that doubling the glass thickness doesn't double your acoustic protection. So if you go from 3mm to 6mm glass, it doesn't necessarily give you twice the protection. And here in this image, you can see how sound is affected by glass in the illustration there. Some is reflected, some is absorbed, and some transmit through to the internal space. So the second principle that says that different glass thicknesses will actually give you different acoustic attenuation. If in a, say, a 10mm piece of glass, you use a 4 and a 6mm in a laminated glass, that'll actually give you better sound attenuation than if you use two 5mm pieces of glass. Now, generally, that won't come up in an RW factor that's against a product, but if you're actually looking at different products and you're getting to that scope, that detail of scope, you can actually request the information from the manufacturer and they can help you decide that. Greg, are you there?
Can you hear me now, Larissa?
Yes, yes.
Oh, great.
Great, Greg's with us.
Hi, everybody, and sorry about that. Thank you for your patience. Yeah, so just to carry on from what Larissa was saying there, and look, there are a number of products that can meet these sorts of needs. So within our suite at Viridian, we've got our acoustic hush lam, so a hush laminate is what we call it, but of course there are a number of other products, and that across the market that will also meet that sort of requirement. And basically it's got a specialized interlayer between the two pieces of glass that is laminated into the panel, so it holds the two pieces of glass together. And that like I said, that can become available in a 6.5mm, 8.5mm, 10.5 or 12.5, and that's in an annealed format. So in other words, it's two pieces of float glass, not toughened, float glass that is laminated together by that 0.5mm special acoustic PVB interlayer. So that can be very, very effective at cutting out noise. Now, another very effective way, as Larissa has mentioned before, was to create a gap between glass, and that's where you can use an insulated glass unit. So that's a specially built insulated glass unit, and the bigger the gap, the better the acoustic performance. And of course, you can use secondary glazing options, which is where you've got glass, the outer glass framed in, and then a 100mm gap, and then another piece of glass glazed on the inside of the the area. So basically, you're creating quite a large air gap between the glass, which then creates a really good sound insulation. Also within that too, that you've got the acoustic performance, but then at Viridian, we also have a product called Comfort Hush, and it's just so you're aware that it's available. Comfort Hush is actually a combination between a low-E performance glass, in other words, an energy performance, and also the acoustic. So we've combined energy efficiency or energy performance in the glass, as well as acoustic performance or noise performance as well. So that's sort of a combination between energy efficiency and acoustic efficiency. So that's just something for you to be aware as far as products on the market goes, that you can combine both. And again, similar to noise, from an energy perspective, you increase the energy performance by creating air gaps, whether it's in an insulated glass unit or a secondary glazed option. You can increase the energy performance. So it has a double, I guess, positive impact by being able to have an acoustic benefit as well as a low E or energy efficiency perspective benefit as well. So that can be really, really effective. Just so you're aware, I mean, there's some really good information available on our website as well that can help you sort of work through a lot of the glass options that are available to you. And that's just at viridianglass.com. So that can be very, very helpful to help you just sort of work through what sort of glass options are available and the different performance data that's associated with the different glass options, whether that be single glass being a laminate, 6.5 millimeter as an example, laminated, or going into the double glazed IGU unit as well. So all that data is available on our website for you as well to get easy access to.
Thank you, Greg. What I'll do is I'll put up a little slide there now. That's both got Greg and myself, our information. So I'll leave that up, and I'm just going to go across to see if there's any questions that people have. I believe there was one, and I need to have a little look. A toughened version of Comfort Plus. Greg, this might be a good one for you.
I'm happy. Thank you, Genesis. Yeah, look, there's that has to be custom made. So in its annealed format, Comfort Plus, whether it be Comfort Hush, which is the acoustic combination with Comfort Plus, or just Comfort Plus itself, which is just the energy performing glass, then that comes in its annealed format, and that's the cheapest option. Or it can be toughened and heat strengthened, but it has to be built individually. In other words, we have to cut to size the specific piece of glass that you will require for that particular space, and then we have to laminate it accordingly. So it's basically a custom laminate. But the short answer to your question is yes, we can create or custom make a toughened version of Comfort Plus.
That's interesting. I've never actually seen that over my time. Is actually a piece of laminated glass that's toughened. I suppose I'm more familiar with seeing it in an IGU, and you'll actually have one layer which will be toughened or heat strengthened for thermal protection. So that's where I see it more often. So Genesis has got another question there. What recommendations can be made for glazing behind the hot plate that requires acoustic and energy requirements?
Well, anything behind a hot plate will have to be toughened. So that laminate isn't really an option for behind a hot plate because the interlayer can be damaged. So the best way would, if it's a window that's behind a hot plate, would be to go with a double glazed unit where you could put toughened on the inside panel, which is closest to the hot plate, and then a toughened glass on the outside of the window as well. So my suggestion would be to go with a double glazed unit for a window that is above or within close proximity to a hot plate.
Genesis, I have a question from Daniel. It might be a good idea for you to get Greg's details and actually have a dedicated chat to him about your project. But Daniel's just come up with a question here. Is there much difference between a 10 mil air gap and say a 16 mil air gap in terms of sound? Would it be insignificant? Now, the difference between a 10 and a 16, you will actually get more sound attenuation. But what happens is it really is not going to register very much. So yes, I'd agree that would be insignificant. What happens is Greg was talking earlier about the 100 mil air gap, and that air gap will allow a space for sound to deaden before it gets much larger. And after about 120 mil, it starts to get resonance issues and things. So really, if you're looking for, if the air gap, a 10 to 16 mil air gap will give you some sound attenuation. But if you're looking for a dedicated solution for sound, you need to go to, well, I'd say 100 mil. There are some 50 mil air gap options on the market these days that I've seen around for glazing products, but really the 100 mil is going to give you the best protection. I just wanted to, I don't know if there's any further questions behind there, but our information is up there and you are very welcome to contact us and ask us whether it's specific for a project or sort of more general information. Very, very happy for you to do that. I'd like to thank Greg for joining me, the Jennifer and the BDAA for introducing us, and for you guys for being attentive, because we've been through a lot of information today. So if you'd like some help with scheduling your glazing schedule or specifying acoustic products, please feel free to contact me. And if you're interested in further information on either acoustics or other areas of glazing, I do have a glazing is technology series, so you can contact myself about that or the BDAA. And as glazing is under the NCC spotlight at the moment, I'm in the process of developing a Crossing the Threshold CPD series, which will be a lot of that glazing is technology information. And that will be released in the first quarter of next year. So that goes into a lot more detail, technical information, resources. We do a lot of experiments to actually give you clarification in all aspects that we possibly can. So I think I'll hand back over to Jennifer now.
Very much, Larissa and Greg. That was really informative. So if there are any other questions that come up, please post them still, and I'm sure Larissa and Greg will be able to get back to you. Our second presenter today is Graham Hunt. Graham, are you with us? So Graham is an architect with over 30 years experience, mostly in the area of environmentally sensitive design. He also has nearly 20 years of experience as an accredited Mathis assessor and has completed hundreds of thermal comfort and basics assessments. We were first introduced to Graham at the National Virtual Design Conference when he spoke about how to achieve a 7- and 8-star home. And today, Graham is going to be discussing the whole of house energy requirements, but also covering energy efficiency in general and the need to move away from gas appliances. Hi, Graham, good to see you.
Afternoon, Jennifer.
I'm going to hand over to you now.
Okay. And thank you to you and the BDAA for this opportunity. I'll just share my screen. I have quite a lot to cover today. I'm going to be talking about whole of house energy, how it particularly relates to the upcoming changes to the NCC and to the NATA's home energy rating scheme. I'll be touching on the trajectory for low energy homes, which is the forerunner for all the changes that are coming. I'll cover briefly the proposed changes to the NCC in 2022 in terms of energy efficiency requirements only for the residential component. I won't be covering commercial or Section J. I'll talk about the expansion of the NATA scheme that has to occur in order to cover the whole of house energy assessment. And it's also going to be expanded to cover existing homes. I won't go into that much in detail, but just to alert you to the fact that that will be coming in the next 12 months to 2 years. I will discuss briefly what you need to think about when specifying equipment and appliances when considering doing a whole of house energy assessment. And I'll also look at the issues around whether you design an all-electric home or whether you choose gas appliances. So the trajectory for low energy homes, it has come out of a requirement of the National Energy Productivity Plan, which has set a 40% energy productivity improvement target by 2030. And that started in 2015. It was originally started by what was then the Department of Energy. It's now become the Department of Industry, Science, Energy and Resources. And they undertook a consultation stakeholder process through 2017 to 2019, which was very successful. There were over 600 stakeholders contributed to that process, from industry, all various jurisdictions involved, as well as consumer groups. The outcome of that trajectory, there were 3 main recommendations. The first is that the trajectory towards zero energy and carbon ready homes should be set. So a time frame and some goals around that to be determined. That trajectory should address broader policy issues and not just emission reduction. So other concerns here were about the cost of energy to consumers, about health and amenity issues, which is becoming a more crucial thing as we face the stresses from climate change, the heat wave we're going through at the moment. It was interesting, there was a report on the radio yesterday that the ambulance service over the weekend were as busy as they were at Christmas or New Year. It's a little known fact that the deaths from exposure to heat is one of the highest killers we have. And so there's a concern to improve the performance of housing to minimise those impacts. The third recommendation was the energy usage budget be quantified with the National Construction Code. So COAG, which no longer exists, is now replaced by the National Cabinet, but in December in 2018, they adopted the recommendations of the trajectory, and there's a report about how it applies to homes. It also covered commercial buildings and new homes. It's a result of Measure 31 under the National Energy Productivity Plan, is setting the agenda to improve the NCC to achieve the 40% productivity improvement. And this is in line with the overarching National Construction Code goals of sustainability, health, and amenity. There was a lot of work done prior by ASBEC and Climate Works as background for the trajectory, and I've got the references there for those 2 reports if you want to get more background. I can make a copy of this presentation available so people can access those links. So in regard to the proposed changes that are going to occur in 2022, because of the extent of the changes have been delayed. Normally they occur around May in the calendar year, and that has been delayed to September 2022 because of the amount of development work that is still to be done. One prime reason for these changes is that there's been no real increase in the stringency of residential energy efficiency within the National Construction Code since 2010. which is 10 long years. And that's when the 6-star NATAS requirement was introduced. So there's been a strong feeling through industry and the community that this increase is long overdue. In mid-2019, the Australian Building Codes Board released a scoping study of how these changes could be incorporated into the NCC, and there's a link to that study there. The outcome of that is primarily what the changes are going to achieve is that new dwellings will be aiming to achieve a net zero regulated energy, as well as a minimum 7-star NATAS rating. There's a definition there from the Australian Building Codes Board of what net zero regulated energy actually means. And the regulated services that are included, which are space conditioning, heated water systems, lighting, pool and spa pumps. They are not covering other energy uses such as portable appliances, plug-in loads, cooking equipment. The idea is that your energy demand is offset by the installation of on-site renewables, which need to generate an equivalent amount of energy that would cover your consumption. The Australian Building Codes Board are developing 2 options for overall energy allowance. Option 1 is to achieve net zero regulated energy and to offset that by on-site generation and storage. Option 2 is to set a maximum energy usage budget. This chart gives an indication of the difference between those 2 options. 0 here being net zero regulated energy, the columns A, B, C and D indicating the different loads, space conditioning, heated water systems, lighting, pool and spa pumps, and E being the on-site renewable energy generation. E should obviously try and balance A to D. Option 2 will set a yet to be determined level that perhaps is more reasonable or might apply where it's not possible to have on-site generation, and that would be an energy budget that you would need to work to. So allied with adding all these energy assessment requirements into the NCC, it was realised that the NATAS Home Energy Rating Scheme needed to expand. Currently, it only rates the building envelope, the thermal performance of the building envelope. It doesn't consider or model, model the overall other energy uses within the home. So the tools, NATAS tools, are being expanded to include these whole of house elements. There already were some tools available. Basics, practitioners within New South Wales who are familiar with basics would be aware that it already covers energy use in terms of the selection of hot water, heating and cooling systems, lighting options. So it has been considered as one model, but the Accurate, the CSIRO NATAS tool, is being expanded to include these other elements. So currently the testing of those tools is underway. The other thing that needs to occur is the NATAS assessors need training in these new modules of the tool. So currently the strategy and courses for that training is underway, and that training will occur next year and early into 2022. As I mentioned, existing homes, there's development underway. This is to cover the potential use by jurisdictions of disclosure of a house or a dwelling's energy consumption to be used perhaps at the point of rental or the point of sale, similar to the scheme that's currently under use in the ACT. There's also interest in terms of using it for social housing, for vulnerable households, and it's likely to be modelled on the Victorian residential scorecard, which is currently being used in that state. This diagram gives you an idea of just the concept of the modules that will be incorporated in the NATA's whole of house. We have the existing current thermal shell module, and it'll be expanded to cover heating and cooling appliances, hot water, lighting, pool pumps, and on-site generation. As I said, these other loads, cooking and plug-in loads, are not regulated, but they will be included in the tool if you want to include that in your assessment as an optional. There are considerations. The trajectory is a long-term plan, so the scheme will develop further over time, and so there's consideration of other modules which may be included in the future, such as electrical vehicles, the use of smarter control systems that are now coming into homes, and so forth. Just quickly, in terms of some of the appliances and things you need to consider. Obviously, there's a range of options with hot water, but obviously you're going to get more benefit in your assessment if you choose a more efficient system, such as solar hot water, evacuated tube, or a heat pump. Where the hot water system is placed within the building can affect the efficiency in terms of the minimising pipe runs, but also where it's placed in terms of is it a good position for the performance of the system. You need to think about hot water pipe insulation, something which is quite often overlooked in the residential area. And selecting efficient sanitary fixtures, efficient shower heads and so forth. They have come a lot more, have developed a lot in recent years. You can now get quite good 4-star shower heads, which are a rain shower head. A valve cozy is a concept that it's an insulated cover to go over the pressure relief valve of a hot water system or tank that can lead to heat losses. And you also need to think about hydronic and pool heating and the efficiency of those systems for heated water systems. Heating and cooling, there's a lot, this is a big area, but the first thing I guess you can do is design an efficient building and to get a good NATA's rating. I spoke at the conference about going beyond the minimum and trying to achieve 8-star designs or more. The benefit with doing this is that you then don't have to put in as big an air conditioning or heating and cooling system, and it will run much more efficiently. The benefit of ceiling fans in tropical and warm, humid climates is very beneficial, and even in all climates for summer cooling. And there's more under the new deemed to satisfy provisions in the NCC 2022. You'll see ceiling fans probably figuring more prominently. Heat pumps, we're very familiar with these, but they are very efficient in terms of well, they take energy out of the air and in terms of their conversion of energy to heat are very efficient. Gas heating is still used a lot in southern states, and the efficiency of newer systems are quite good, but you have to be ensured that they're installed properly, especially the ducted systems. The use of shading and ventilation can certainly help to reduce the demand for cooling. Pools and spas will also factor. Be aware that pool pumps are going to be energy rated from next year as a minimum. Well, they'll all be rated, so you'll be able to choose quite easily which are the more efficient pumps, and the efficiency of these pumps has expanded significantly during the last decade. We did discuss the heating options. Perhaps using heat pumps is a consideration, especially if you're needing to install a PV system to meet your energy budget. These can work in conjunction with a heat pump to ensure that you probably can get, a heated pool with minimal emissions and minimal cost. Pool covers help to contribute to minimizing evaporation and keeping the heat in, so it's not escaping. And considering the size of a pool, because obviously the bigger it is, the more energy it needs to consume to just circulate the water, but also, for heating. And there's also now quite a few options around natural pools using reed beds and other options, which can reduce the energy demand and be better for the environment. I'll just briefly now cover a brief discussion about choosing between electric and gas appliances. I've actually borrowed this from Renew. I'm not sure if you're familiar with them. They used to be called the Alternative Technology Association. They publish the magazines Renew and Sanctuary. And they've done a lot of research about the benefits of converting to an all-electric home. And this is just results of some of their research. So this is a summary of overall energy use in a typical house in Melbourne. And you can see that heating is the biggest component and hot water. The next, sorry, too fast. The next one is a typical house in Brisbane. And you can see the heating is significantly reduced and cooling is more important. But the overall component for heating and cooling is significantly less, meaning that your appliance load proportionally becomes bigger. But the question is, isn't gas still cheaper and lower emissions than electricity? I see there has been a question about basics rating gas more efficiently than electricity, and that's to do with gas does have lower emissions than electricity produced from coal-powered power stations. But that's not all. This chart shows the electricity and gas emission factors by state, where the electricity is in blue and the maroon is the gas. And you can see that the emissions from electricity is, 3 to 5 times larger. And primarily that's because of the coal, burning of the coal. But there are some things that are not quite covered in these figures. And one is what's called fugitive emissions, which is where you get gas leakages from the reticulation system. And we have an aging reticulation system. And it's also through the production and the movement of gas through pipelines. And so that has not been traditionally fully included. And more increasingly, our gas, we no longer have the Bastrate gas fields, and we are relying more on non-conventional gas extraction, coal seam gas and so forth, which leads to higher emissions and higher cost in terms of delivery of the gas. And the other thing it doesn't include is that any on-site solar PV production will minimise the emissions, and the fact that the electricity market is transitioning to becoming greener, and that has been happening fairly slowly, but it is going to speed up. We've recently had states such as New South Wales committing to a 70% reduction to using renewable energy by 2030. So you'll find over time the higher blue columns will start to come down. But the other thing that comes into play is the efficiency of the appliance. So you're probably familiar with the coefficient of performance, or the EER measure of an equipment, and that's the relationship of the energy in versus the energy out. This chart shows the coefficient of performance for different systems. On the left, you've got your traditional electric resistive, your radiator bar heater, where it's 1:1. Your older gas heaters and gas ducted heating is down to 0.4 because of losses through the system and just inefficiencies of the burners. More efficient gas systems can get up closer to 1, but a reverse cycle heat pump can vary from 4 up to 5.5, the really efficient ones. And the same applies to hot water systems. And you can see an electric heat pump is, significantly more efficient. And there's the gauge of the extent of the improvement in terms of the amount of actual energy you're consuming to get your heat or your cooling. So as summarised here, gas can be 1 to 3 times less emissions than electricity, but electricity can use 4 to 13 times less energy than gas. And so switching to electricity will, over time, lead to savings. And as we go to a greener grid, those savings will increase. And here's just some charts which show some predictions around the likely savings over a 10-year net present value assessment. And you can see from these different locations around the country that the locations that have the higher heating demand, such as Hobart and Melbourne, Armidale, you can see that there's quite a significant return over time. And especially if you ally it with a PV system on the roof. And this is the same sort of research explaining what can be achieved with existing homes in terms of whether the home is large, medium, and someone's at home during the day, or medium and out during the day working, or a small home. And again, the colder climates, you can see there's significant savings. In the southern states, there is a lot of gas heating still being used, ducted gas heating, but at the same time, a lot of those houses have fitted reverse cycle air conditioners for cooling. They would save a lot of money if they use the reverse cycle air conditioning for heating in the winter and perhaps turned off the gas. There is an interesting presentation by Tim Forsey, who's from the Facebook group My Electric Efficient Home. And that was a presentation he did for Renew, and that gives a lot more clearer explanation about the benefits of using heat pumps. So just in summary, I've just got some references here. The NCC 2022 draft for public consultation will be occurring in the middle of the next year. So there's a link there for how you can access and can contribute to that consultation. And I think the more people that get involved, the better the outcome will be. If you want to know more about the changes to NATAs, there's a link there to the NATAs website. I've mentioned the work of Renew. There's a lot of great resources there, and they also have on their YouTube channel a lot of videos about these type of topics. There's Your Home, which is a very good resource from the federal government. There's a new edition of that coming out early next year. And I've come here at being a member of ABSA, and you will need an experienced accredited assessor to work through your new whole of house energy assessment. So you'll find very many capable assessors there. And I'm from Delisle Hunt Wood Architects, and our website address is there. That's all, so I'm happy to take any questions.
Hi, Graham. I'm going to read a couple of questions out that have come through. Tommy Struger has asked, will BASIX continue to prefer instant gas over heat pumps in the future?
Well, I don't know the answer to that. I think that will depend how much the New South Wales grid changes and whether in time they need to reassess the emissions that they've attributed to electricity within their tool. But I'm not aware of any moves at this point to do that. And also, it hasn't been clear whether BASIX will be updated to match the NCC changes in 2022. There is slight variations between the two, and that's something that the actual outcome of that hasn't been made clear at this point in time.
Tommy's also asked, will air tightness be included in the NCC to address energy use like the passive house standard requires?
Well, there was some update to air tightness and sealing in 2019. At this point in time, it's not looking to be addressed any more detailed. They're certainly looking at things like thermal bridging, and that's likely to be updated within NATAs and within the NCC, but not air sealing specifically.
And Tommy has asked, will BASIX continue to prefer instant gas over heat pumps in the future?
Well, again, that relates to whether they will change their emissions rating if the grid becomes greener. That's the only reason they would change that. And I don't know if they're planning to do that. They haven't made any indication at this point.
There are just some other comments in the chat box, which I just have to go back and have a look at. One about bathroom floor heating, which I'm not sure if that's a comment or a question about losing the bathroom floor heating.
Well, if it's a small bathroom, it's fairly insignificant. Currently, it's not considered within BASIX. It hasn't been indicated whether it's going to be considered in the whole of house assessment as yet.
There's a question from Raphael about how well do air conditioning and floor heating systems work with a solar PV system with battery backup?
I didn't quite catch that.
I'm not sure if it says, how well do air conditioning and floor heating systems work with a solar PV system with battery backup?
Well, it depends on the efficiency of the system and when you're needing that heating and cooling. But obviously a heat pump system, whether it's for floor heating, hydronic, or for air conditioning, are much more efficient. The hot water systems, some of the better performing ones, come with inbuilt timers, so you can set them so they only come on during the day when your PV system is producing power, and that's a fairly efficient way to do it. It's a bit trickier with air conditioning because you obviously want them be able to turn them on at any time depending on conditions. but it's a matter of sizing your air conditioning to your PV system to cope, and your battery system to cope with the demand from your air conditioner. But I think more importantly, before that, it's important to make the house efficient. So through the natters, through developing your thermal envelope so that your demand for heating and cooling is minimised.
There's a few more questions in the chat box, but I'm going to have to wrap the meeting up. I'm wondering, Graham, if you can access that chat box, maybe you could answer some of those questions directly.
Yeah, sure, I'll try.
If you're able to do that. So that concludes our meeting for today. There'll be a QR code on the screen. There we go. So the BDAA office will be closed from 3 p.m. on the 23rd of December and will reopen on the 5th of January 2021. So there will be no online chapter event in January, and the next one will be Tuesday, the 2nd of February at 1 p.m. So thank you very much for everyone for joining us, and thank you to our presenters. The BDAA wishes everyone a very safe and happy holiday season, and we'll see you all in the new year. Okay, bye for now.